Today I'm going to talk about something which makes us truly unique, unless you're an identical twin. This, of course, is our DNA. What does DNA even stand for? Well, it actually stands for deoxyribonucleic acid, but it's a lot easier to remember DNA. You might have heard of this before, but what actually does it do? Well, your DNA is your genetic information. It's how our cells know what to do, the orders to follow. But you can think of it a lot easier, just like an alphabet of instructions. Ours, English language, we have 26 letters, A through to Z. But DNA is actually a lot simpler. It only has 4 main letters. You might have heard of them previously, but these are A, T, C, and G. The full names are adenine, thymine, cytosine, and guanine. But why have I written them like this? Well, this is because we have what we call a base pair rule. These bases are complementary. It doesn't mean that they flatter each other. It means they like to pair with each other and only with each other. So cytosine always pairs with guanine and adenine always pairs with thymine. You can come up with your own mnemonic to help you remember this. The favourite one I've heard is always try good curry. ATGC. It's quite easy to remember once you've got your own method, so I recommend you work on yours. But we can put this all together to actually look at the structure of DNA. So we today are going to try and make our own model of what DNA looks like. And I'm going to do that using some simple things, some sweets and some toothpicks. So what I have is I have some long straws. This is going to represent what we call our backbone to hold everything together. And I have some jelly tots of 4 different colours. So I have a red jelly tot, a green jelly tot, a yellow jelly tot, and a purple jelly tot. And I'm going to colour code mine, so I have this. Cytosine in red, guanine in green, adenine in yellow, and thymine in purple. So in other words, red will always pair with green, because cytosine always pairs with guanine, and yellow always pairs with purple, because adenine always pairs with thymine. So I have a toothpick and a yellow tot, sorry, a red tot, and so that's going to pair with guanine, which is a green tot. And this just represents, the toothpick just represents the bond between the two. So there is my complementary pair of my cytosine and my guanine. What's going to happen is I've got 2 of my chewy streets here, and that's going to represent our backbone. What we're going to do is just build up all the way down with some I've already prepared. And this is going to represent the base structure of our DNA. So these can be in any order that you would like, because DNA has a set order, but we're not going to worry about that specifically. The one you create could be different to your friends, your family, and that just makes up exactly what happens in real life. Everyone has their own DNA order, their own DNA structure. As long as we always have the same 2 colours pairing together, use any sweets that you want. So in my case, we've always got red and green together, and yellow and purple together. That'll be the same for you. Whichever 2 colours you choose will be the same the whole way down. So, as you can see now, I've created a little bit of a ladder structure with my sweets and my toothpicks, and then these 2 straws down the side is what I'm calling my backbone, which holds them all in this set order. Now, you may have heard that DNA has a very specific shape to it, and it's not this ladder that we're seeing now. It's what we call a double helix. So this actually can bend, which is why I use these sweets. It actually can curl round, and it starts to create that double helix shape that we might know. It's like a twisted ladder is the way to remember it. Well, that's the way I remember it anyway. But I was mentioning that we have it always in our cells. So here is my animal cell, and our DNA is located in our nucleus just here. But our DNA is not this short little strand that we can see here. Our DNA is actually thousands and thousands of these little rungs of our ladder, you might think. these complementary base pairs together. And what actually happens is we can twist it so much, it actually compacts down. And you can see this takes up a lot less space than my previous ladder when we expand it back out again. And that's how it gets into your cells. It curls up completely, so we have it all wrapped up nice and tight, and we end up with what we call chromosomes. And it's all wrapped up together and compacted in, and that's what can fit inside of our DNA. So I hope you take great fun making your own DNA strands. Just use something that you can eat afterwards and get really fulfilled